Hi everyone, my name is Thomas Kim. Today is 31st August 2023. It is 7:51 a.m. In this episode, we will solve some problems from Calculus Early Transcendentals 9th edition by James Stewart. Click this button, scroll down, chapter 16, line integrals. I would highly recommend you to read the text very carefully. Don't miss a single word. Don't miss a single problem. Read each word and understand what the text says. Scroll down. Section 16.2 Exercises. We will solve problem 20. Also, scroll down. We will solve problem 52, problem 53, problem 54. In problem 54, we solve Ampere's law. This problem. Problem 20. The figure shows a vector field F and two curves C1 and C2 are the line integrals of F over C1 and C2 positive, negative, or zero. Explain. In this figure, the blue arrows represent vector field F. We have curve C1, curve C2. Curve C1 is oriented in this direction, counterclockwise. Curve C2 is oriented clockwise direction. Now, I will give you 10 seconds. Give the answer. If you can't solve this problem in 10 seconds, you have serious problem. You do have a serious problem. This is statistics for my YouTube channel. 11.9, 12% of my audience comes from India. 9.9% comes from United States. I also checked viewer age. 40.6% in their early 20s, 43.5% in their late 20s or early 30s. The C++ programming language, Special Edition. This is actually third edition of the famous book, The C++ Programming Language by Van Strostrup. I read this book around 2003. Before I read this book, I was already familiar with the C++ language, but still, it took me almost 6 full months to completely understand this book. I'm saying that I was already familiar with the C++ language before I read this book, but I spent another 6 months to completely understand Van Strostrup's The C++ Programming Language. After reading this book, I created a complete scripting language called Yet Another Language. I actually created an interpreting language. My point is, if you develop or improve your book reading skill, you can learn almost anything effectively. For example, in Pix Calculator Siliconian. In this video, I explained recursive descent parse tree and how to create in Pix Calculator. I learned recursive descent Path Tree by reading this book. After learning Recursive Descent Path Tree, I could read any advanced text. I could read such proposal paper all on my own and can completely understand these specifications in Recursive Descent Path Tree. If I haven't read this book carefully, I would still cannot understand what all these things are. Book reading skill is critical for your successful career. I always emphasize reading books from cover to the last cover. Once again, I always emphasize that you should read your book from cover to cover. Why? There are very good reasons. First off, you have to understand the intentions of your book author. Read preface. Don't skip preface. The preface usually contains the philosophy of the book of the authors. A great discovery solves a great problem, but there is a grain of discovery in the solution of any problem. Your problem may be modest, but if it challenges your curiosity and brings into play your inventive faculties, and if you solve it by your own means, you may experience the tension, the thrill, the joy, the enlightenment, the ecstasy, the orgasm, and enjoy the triumph of discovery, and feel you are standing at the top of the world. Don't skip preface. Once you read one passage, think about what the passage says to you. After each passage, think what the passage is saying to you. The art of teaching, Mark Van Doren said, is the art of assisting discovery. In this 9th edition metric version, as in all of the preceding editions, we continue the tradition of writing a book that we hope assists students in discovering calculus for both its practical power and its surprising beauty. We aim to convey to the students a sense of utility of calculus as well as to promote development of technical ability. At the same time, we strive to give some appreciation for the intrinsic beauty of the subject. Newton undoubtedly experienced a sense of triumph when he made his great discoveries. We want students to share some of that excitement. The authors of this book aim to convey to the students a sense of the utility of calculus as well as to promote development of technical ability. The authors strive to give some appreciation for the intrinsic beauty of the subject. The authors want students to share some of that excitement. The emphasis is on understanding concepts. Nearly all calculus instructors agree that conceptual understanding should be the ultimate goal of calculus instruction. To implement this goal, we present fundamental topics graphically, numerically, algebraically, and verbally, with an emphasis on the relationships between these different representations. Visualization, numerical and graphical experimentation, and verbal descriptions can greatly facilitate conceptual understanding. Moreover, conceptual understanding and technical skill can go hand in hand. each reinforcing the other. The emphasis is on understanding concepts. Nearly all calculus instructors agree that conceptual understanding should be the ultimate goal of calculus instruction. The ultimate goal of calculus instruction. After each passage, think what the passage is trying to convey to you. What is conceptual understanding? What is technical skill? Conceptual understanding provides you the strategies for solving problems. Technical skill is the means to compute your answer. Without concrete conceptual understanding, you do not have a strategy to attack your enemy, the problems. But still, if you do not have the means, the skills to attack them, you cannot win the war. So, conceptual understanding or your strategy to the problem is extremely important, but we cannot ignore technical skill. The message says conceptual understanding and technical skill can go hand in hand, each reinforcing the other. Your strategy sharpens your technical skill. Your technical skill provides you better strategy to your problem. The ultimate goal of calculus instruction. To implement this goal, we present fundamental topics graphically, numerically, algebraically, and verbally, with emphasis on the relationship between these representations. Visualization, numerical and graphical experimentation, and verbal descriptions can greatly facilitate conceptual understanding. Only idiots skip preface. I would also recommend you to read To the Student. Reading a calculus textbook is different from reading a story or a news article. Don't be discouraged if you have to read a passage more than once in order to understand it. You should have pen and pencil and calculator at hand to sketch a diagram or make a calculation. Some students start by trying their homework problems and read the text only if they get stuck on an exercise. We suggest that a far better plan is to read and understand a section of the text before attempting the exercise. In particular, you should look at the definitions to see the exact meanings of the terms. We suggest that a far better plan is to read and understand a section of the text before attempting the exercises. In particular, you should look at the definitions to see the exact meanings of the terms. And before you read each example, we suggest that you cover up the solution and try solving the problem yourself. Now, in section 16.2, line integrals, Figure 13. Figure 13 shows the force field and the curve in example 7. The work done is negative because the field impedes the movement along the curve. The curve is oriented counterclockwise direction. Look at the arrow. The curve travels counterclockwise orientation. The vector fields impedes the movement along the curve. If you haven't skipped reading Figure 13, then you can solve problem 20 instantly. The curve C moves in the direction of the vector fields. The blue arrow, does not impede the movement along the curve C1. In case of curve C2, the vector field does impede the movement along the curve C2. So, line integral along the curve C1 is positive. It does not impede. Line integral along the curve C2 is negative because it impedes the movement along the curve C2. The figure shows a vector field F and two curves C1 and C2 are the line integrals of F over C1 and C2 positive, negative, or 0. Explain line integral of vector field F dot dr. This R is defined over curve C1. This can be written F dot T ds over C1, where T is dt over dr, dr over dt. Unit tangent vector ds, the arc length of curve C1. So, it can be said that magnitude of F, magnitude of T ds over C1. We missed cosine theta. T is unit tangent vector. So we can say magnitude of F cosine theta d theta. I will scroll down. Unit tangent vector. This angle theta. Unit tangent vector. This angle is theta. This angle is theta. This angle is theta. This angle is theta. Unit tangent vector. This angle is theta. Cosine theta is greater than 0, less than 1. When theta is greater than 0, less than 2 pi. This theta, this theta, this theta, this theta, this theta, all thetas are less than 2 pi. So this value is positive. We accumulate positive values. So it is greater than 0. In this case, this is theta, 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 because this is our unit tangent. Our unit tangent. This is theta. This theta is greater than 2 pi, less than pi. Cosine theta is greater than negative 1, less than 0. When theta is greater than pi over 2, less than 5, because cosine graph makes like this. This is 0, this is 2 pi, this is 5, 0. This is cosine theta. In this interval, cosine theta is less than 0. So we accumulate negative values along the curve C. Line integral of f dot dr along C2 is less than 0. I made a simple mistake here. It should be ds. After solving your problem, you have to think why the author of this book posed you this problem. Why the author posed this problem? He probably wants to make sure his audience understand the definition of a line integral. Scroll down. We will now solve problem 52. Sorry, I changed my mind. Instead, this is 16.2 exercises. Scroll down. Solve problems 51, 52, 53, then 54. Please understand problem 54. This problem is quite challenging. Solve this problem on your own.